In addition, brine pools are regions of high primary productivity. Food is scarce in the deep sea. The lack of sunlight means there are no photosynthesizers like plants or phytoplankton to generate energy.
Imagine sinking thousands of feet into the ocean's midnight zone, only to see a literal lake materialize in your submarine's headlights. It has a distinct shoreline, ripples on its surface, and a warm, inviting current. But if any creature dips a single limb into this water, they freeze instantly. They don't just die, they stop moving forever. Their bodies mummified on the spot. This is a real toxic phenomenon hiding on our planet's seafloor. Welcome to the underworld of brine pools. Where did the lake come from? The descent into the deep ocean is a journey of systematic erasure. First, you lose the red wavelengths of light, then the yellows, and then the greens. By the time a research submersible passes 1,000 feet, the sun is no longer a physical presence. It is a memory. Keep dropping. At 2,000 feet, 3,000 feet, the pressure outside the thick titanium hull escalates to over 1,000 pounds per square inch. It is an environment of absolute stasis, a pitch-black void where the water temperature hovers just above freezing, and the landscape is a monotonous desert of gray abyssal mud. But then, the powerful halogen floodlights of a robotic submersible pierce the gloom, and the desert suddenly ends. What materializes in the high-definition cameras isn't just a change in geology, it is an impossibility. Ahead lies a distinct, unmistakable coastline. There is a beach of dark sediment, and beyond that beach is a body of water resting inside another body of water. The surface of this subterranean lake ripples. It has its own distinct currents, its own small waves lapping against the shore, and a dense, shimmering mist hanging just above its surface. To the human scientists sitting in a control room miles above on the surface, staring at the live feed, the brain undergoes a moment of cognitive dissonance. Every instinct tells you that you are looking at a lake on dry land, perhaps a scenic overlook in a desert canyon at dusk. But the telemetry data doesn't lie. You are looking at a lake sitting at the very bottom of the sea. This is the physical reality of a deep-sea brine pool, an oceanographic anomaly that defies standard intuition about how liquids behave. When scientists first stumbled upon these features, they called them lakes of the deep. But as exploration advanced, the descriptions grew more unsettling. The specific pool that captured global attention in the northern Gulf of Mexico was designated by its discovery team as the Jacuzzi of Despair. The name is entirely literal. While the surrounding deep-sea water is a bone-chilling 36 degrees Fahrenheit, this hidden lake registers a balmy, almost inviting 66 degrees Fahrenheit. It glows with an eerie, distorted warmth in the cold dark. When a submersible approaches the edge of this pool, the visual phenomenon becomes even more surreal due to an optical boundary known as a halocline. A halocline is a sharp vertical gradient where water masses of completely different salinities meet but refuse to mix. Because the water inside the pool is packed with dense concentrations of dissolved ancient salts, it is significantly heavier than the surrounding seawater. The two fluids possess entirely different refractive indices, meaning they bend light differently. As the robotic vehicle hovers over the shoreline, the camera captures a spectacular visual warping. The boundary line looks like a thick fluid mirror or oil swirling on top of water. If the submersible pushes its robotic arm down into the pool, the arm seems to bend and fracture visually, breaking through a liquid ceiling. The surface of the brine pool can support its own internal waves, driven by the kinetic energy of deep ocean currents passing over it. These waves roll across the surface of the underwater lake, crashing into its banks, breaking against the dark sediments, and curling backward in slow motion due to the immense pressure of the water column pressing down from above. To look at this shoreline is to look at a highly defined physical border. The beach surrounding the Jacuzzi of Despair is not made of sand, but rather a thick, dark crust composed of mineral precipitates and the compacted shells of millions of ancient organisms. It forms a circular rim that rises slightly above the surrounding seabed, acting like the retaining wall of an infinity pool. The interior of the pool is a deep, murky red-brown, a stark contrast to the stark, crystal-clear blackness of the open ocean. This coloration is a warning sign, a visual indicator of a hyper-concentrated chemical soup that has remained trapped in this seafloor depression for millennia. The scale of these features varies wildly. Some brine pools are mere puddles, a few feet across, dotting the mud like small potholes on a neglected road. Others are massive, sprawling inland seas of the abyss. The Jacuzzi of Despair measures roughly 100 feet in circumference and plunges to a depth of nearly 40 feet, shaping it like a perfect circular cauldron. But regardless of their size, they all share this same haunting characteristic. They maintain an absolute, unyielding separation from the ocean that contains them. They are worlds within worlds, governed by their own fluid dynamics, their own temperatures, and their own strict boundaries. As you stare across this alien landscape, the initial sense of wonder slowly gives way to an underlying tension. The water is perfectly clear right up to the edge of the pool, but the moment your eyes cross the halocline, the interior becomes hazy, thick, and heavy. It looks calm, almost serene, basking in its own localized warmth. It looks like a sanctuary in a cold, unforgiving desert. But this visual tranquility is the ultimate deception. The shoreline is entirely devoid of the casual, wandering life found elsewhere on the seabed. There are no fish swimming lazily through its waters. There are no octopuses seeking shelter in its depths. The water inside the pool doesn't circulate with the rest of the ocean. It stagnates, brewing a concentrated environment of absolute toxicity. The warmth it radiates isn't the warmth of a life-giving thermal vent. It is the heat of a chemical reaction that has been isolated from the global water cycle for millions of years. Standing at this boundary line, a human observer realizes that nature has constructed a perfect illusion. It is a masterpiece of geometry and physics, a lake with a shoreline, beaches and waves, fully formed and operating in pitch darkness, thousands of feet beneath the surface of the earth. It invites exploration, drawing the eye and the imagination into its shimmering, undulating depths. But the true nature of this underwater oasis isn't how it looks. It is the absolute, terrifying finality of what happens to any living creature that dares to cross its shoreline and make contact with its water. The chemistry of the crypt. To understand why this underwater oasis is actually a localized wasteland, one must examine the precise, volatile forensic chemistry taking place beneath its shimmering surface. The moment any complex organism crosses the halocline and makes contact with the water of the brine pool, it enters a realm of immediate environmental shock. This is not a gradual poisoning or a slow decline in vitality. It is a sudden, catastrophic failure of biological systems on a cellular level. The water inside the pool is completely devoid of dissolved oxygen, an environment known as anoxic, and is saturated with a concentrated cocktail of ancient, toxic chemicals that have been brewing under intense hydrostatic pressure for millennia. The primary weapon of this aquatic dead zone is its extreme salinity. While typical ocean water possesses a salinity of roughly 35 parts per thousand, the brine inside the Jacuzzi of Despair reaches concentrations up to 5 times greater. When a marine animal like a deep-sea crab or a wandering eel passes through the boundary layer, the physics of osmosis instantly turns against it. In a normal marine environment, an animal's internal bodily fluids are carefully balanced against the salinity of the surrounding sea. When plunged into a hypersaline brine pool, that balance is violently disrupted. The extreme concentration of salt outside the creature's body immediately begins drawing water out of its living cells through osmosis, trying to equalize the concentration. The animal's cells dehydrate rapidly, collapsing inward as their moisture is violently pulled away. Simultaneously, the massive influx of sodium and chloride ions floods the creature's bloodstream, causing its nervous system to misfire chaotically. Signals from the brain stop reaching the muscles, the heart stalls, and the organism is rendered completely immobile within a matter of seconds. But toxic shock from salt is only the first layer of this multifaceted death trap. The brine is also heavily saturated with lethal concentrations of hydrogen sulfide and dissolved methane gas, which bubble up continuously from deep tectonic fractures beneath the seafloor. For any animal that breathes through gills, hydrogen sulfide is an incredibly potent, fast-acting neurotoxin. It binds directly to the iron inside the creature's hemoglobin, effectively blocking its cells from utilizing what little oxygen might remain in its system. It is a form of rapid chemical suffocation that occurs even if the animal tries to retreat. As a result, any creature that accidentally miscalculates the shoreline or gets caught in an internal wave rolling across the pool doesn't just drown. Its internal chemistry is systematically dismantled. The fish or crustacean stops moving, its muscles locking up in a permanent state of rigor mortis, before it sinks like a stone through the heavy, dense brine to settle on the bottom of the lake. What happens next is perhaps the most surreal and macabre aspect of the entire phenomenon. In a typical ocean environment, when an animal dies, its body is quickly broken down by a complex hierarchy of scavengers, ranging from large sharks and hagfish down to specialized bone-eating worms and billions of microscopic bacteria. This scavenging network ensures that organic matter is recycled back into the marine ecosystem within weeks or even days. Inside the brine pool, however, this entire ecological process is brought to a screeching halt. The very same hypersaline, toxic, and anoxic conditions that kill complex animals also make it completely impossible for standard marine bacteria to survive. Without oxygen and under the crushing weight of the salt concentration, the biological enzymes responsible for decay and decomposition cannot function. The bacteria quite simply cannot live inside the pool to eat the dead. Because of this total absence of decomposition, the bottom and the sloping sides of the brine pool have transformed into a literal, pristine underwater graveyard. Over decades and centuries, countless organisms have wandered into the trap, died instantly, and sunk to the floor, where they now lie completely preserved. When scientists maneuvered the high-definition cameras of their remotely operated vehicles over the edges of the pool, they were stunned by the clarity of the scene below. They found thousands of deep-sea crabs, eels, and isopods lying in heaps along the underwater shoreline and down the slopes of the cauldron. These creatures do not look like skeletons or rotting carcasses. Their shells are fully intact, their coloration is eerily preserved, and their limbs remain articulated in the exact positions they held at the moment of their sudden demise. They have been organically pickled, mummified by the extreme salt concentration in a manner not unlike the ancient pharaohs of Egypt, or bodies preserved in peat bogs. They sit there, completely untouched by time, suspended in a chemical stasis that locks them away from the natural cycle of life and death. This phenomenon creates what scientists call the graveyard rim, a stark, visible ring of death that delineates the exact boundary where the toxic brine meets the normal ocean. The outer banks of the pool are littered with the bodies of creatures that just barely touched the water before realizing their mistake, dying on the perimeter. This perimeter serves as a grim monument to the pool's lethality, but it also creates a bizarre, opportunistic feeding station for a very specific group of outsiders. While nothing can survive inside the heavy brine, the absolute edge of the pool, where the water is just diluted enough to tolerate for brief periods, attracts highly adapted, specialized predators. Deep-sea giant isopods and specialized hagfish will cautiously cruise the perimeter of the graveyard rim. Using their sensory organs to detect the scent of preserved organic matter, they will occasionally make daring, rapid dashes into the very upper layers of the halicline. They grab the mummified remains of a freshly pickled crab or fish and quickly pull it back out into the safe, normal seawater to consume it. It is a high-stakes game of ecological theft played at the gates of a chemical underworld. The sheer density of the water also plays a crucial role in creating this eternal crypt. Because the brine is so heavy and packed with dissolved minerals, it possesses a physical viscosity that feels completely different from normal ocean water. It behaves more like a thick oil or syrup. When an animal dies and falls into the pool, it doesn't sink at a normal rate. It drifts downward in slow motion, floating through a thick, heavy medium that resists its descent. This density is so high that light submersibles and scientific instruments must be heavily weighted just to push through the surface of the lake. If a piece of equipment or an organism isn't dense enough, it will simply bounce off the halicline or float suspended on the lake's surface, unable to break through the heavy liquid barrier.
The more salt dissolves in the volume of water, the more dense it gets. The higher salt content in the seawater makes it more dense, so relatively speaking, you become less dense and rise to the surface.
The pool acts as a physical and chemical vault, locking its secrets away from the rest of the planet. To look into the depths of this brine pool is to realize that nature has constructed an environment of absolute finality. The water looks clear, warm, and deceptively peaceful under the camera lights, but its molecular reality is an unyielding wall of chemical devastation. It is an environment where the fundamental rules of biology are suspended, replaced by a cold, forensic process of preservation that turns a vibrant living creature into a permanent statue of salt and stone. The Jacuzzi of Despair earns its name not just through the body count it accumulates, but through the haunting, flawless preservation of its victims. To understand how such a perfect, subterranean death trap could be engineered by the Earth, we have to look back to a time when this vast ocean didn't even exist. The ancient Genesis. To truly understand how a toxic lake can form at the bottom of a colossal saltwater ocean, one must abandon human timescales and descend into the deep time history of our planet's tectonic shifts. The existence of the Jacuzzi of Despair, and indeed the hundreds of other brine pools hidden across the global seafloor, is the result of a catastrophic geological chain reaction that began more than 150 million years ago during the Middle Jurassic period. At that point in Earth's history, the supercontinent of Pangaea was undergoing a violent, slow-motion breakup. As the continental plates ground against one another and pulled apart, a massive depression formed between what is now North America, South America, and Africa. This basin would eventually become the Gulf of Mexico, but before it became a deep ocean, it was a highly volatile, shallow, landlocked sea. During this era, the global climate was intensely hot and arid. The shallow basin of the Proto-Gulf was connected to the open ocean by only a few narrow, treacherous channels. Periodically, tectonic uplifts, or shifting sea levels, would close these channels entirely, cutting the basin off from the rest of the world's water supply. Trapped under a scorching prehistoric sun, the isolated seawater began to evaporate at an astronomical rate. As the water vanished into the atmosphere, the minerals dissolved within it became heavily concentrated. Eventually, the water reached its saturation point, and vast sheets of solid crystalline salt began to precipitate out of the liquid, settling onto the basin floor. This cycle of flooding, isolation, and total evaporation repeated itself dozens of times over millions of years. Each cycle deposited another layer of pure mineral salt, building a colossal, solid subterranean plateau that eventually measured up to 5 miles thick in certain regions of the basin. The story took a dramatic turn as the tectonic plates continued to separate, permanently opening the basin to the global ocean. A massive influx of deep, cold seawater flooded the region, creating the deep marine environment we recognize today. Rivers flowing from the surrounding continents began dumping billions of tons of heavy sediment, sand, mud, silt, and organic debris on top of the ancient salt sheet. Over tens of millions of years, this accumulating layer of sediment grew miles thick, compressing under its own immense weight and transforming into dense, heavy sedimentary rock. It is here that a profound law of physics engineered the creation of the underwater lakes. Solid rock salt is highly unusual under intense pressure. It is relatively buoyant compared to heavy, compacted sedimentary rocks, and it behaves less like a rigid stone and more like a highly viscous, slow-flowing plastic. This physical phenomenon is known by geologists as salt tectonics. As the weight of the overlying rock layers pressed down harder and harder, the trapped ancient salt layer beneath was squeezed like toothpaste. Looking for an escape route, the plastic salt sought out any point of weakness in the crust above it. It began to push upward, forming massive domes, ridges, and subterranean pillars that cracked, fractured, and buckled the heavy sedimentary rock layers sitting on top of it. When these upward surging pillars of salt finally breached the ocean floor, they came into direct contact with the cold, pressurized seawater of the deep abyss. The moment the exposed rock salt touched the deep ocean water, it began to dissolve rapidly. However, because the salt was emerging from deep depressions or flat plains on the seabed, the resulting hypersaline fluid had nowhere to go. Due to its extreme density, the newly formed brine didn't dissipate or mix with the surrounding ocean currents. Instead, it pooled inside the very craters and trenches created by the collapsing seafloor above the salt domes. As the salt dissolved out from underneath the seabed, the overlying rock would often collapse inward, forming perfect, bowl-shaped craters that acted as natural containment vessels. This is the exact birth narrative of the Jacuzzi of Despair. It sits directly on top of a subterranean salt fault line, where a continuous supply of ancient Jurassic salt is being pushed up into the ocean floor, dissolving into a localized depression and maintaining the pool's precise boundaries. This ancient geological heritage also explains the presence of the deadly gases that bubble up from the depths of the pool. The very same ancient sedimentary basins that contain these thick salt sheets are also highly efficient factories for fossil fuels. Deep beneath the salt domes, millions of years of compressed prehistoric organic matter have broken down under intense heat and pressure, transforming into massive reserves of oil, methane gas, and hydrogen sulfide. Because salt is highly impermeable, these gas reserves are often trapped beneath the salt sheets for tens of millions of years. However, when the salt tectonics fracture the Earth and create conduits to the seafloor, these highly pressurized, toxic gases find a pathway to escape. They surge upward along the edges of the salt pillars, dissolving directly into the heavy brine pool and transforming a simple pool of salty water into a boiling, toxic cauldron of chemical devastation. To look at a brine pool today is to look at a direct, physical portal to the Jurassic world. The water molecules inside that pool are modern, but the chemical reality that defines them, the ultra-pure sodium chloride, the sulfur compounds, and the heavy minerals, was laid down by a dying sea when dinosaurs still walked the Earth. The Earth effectively engineered a time capsule, burying it beneath miles of rock and sea, only to slowly squeeze it back out onto the modern ocean floor through the sheer, unyielding physics of planetary pressure. It is a dynamic reminder that the seafloor is not a static desert of mud, but a living, shifting tectonic canvas where ancient history actively dictates modern ecology. Every ripple on the surface of the Jacuzzi of Despair is powered by a geological engine that took 150 million years to build. Yet, navigating a submarine into this toxic, pitch-black cauldron to study this ancient engine requires pushing human engineering to its absolute breaking point. Voyaging into the black. Navigating a machine into a pitch-black toxic cauldron thousands of feet below the surface requires pushing human engineering to its absolute breaking point. In 2015, the crew of the research vessel E/V Nautilus set out to explore the deep valleys of the northern Gulf of Mexico 3, 4, 6. Using their state-of-the-art remotely operated vehicle, or ROV, named Hercules, scientists dropped the robotic craft into the water and watched it sink through the water column for hours. The control room aboard the ship was a quiet hive of concentration, filled with the hum of electronics and the tense murmurs of pilots monitoring real-time telemetry data. When Hercules finally reached the bottom and its cameras caught the shimmering edge of the pool, the atmosphere inside the control room instantly shifted from routine observation to utter shock. The scientists were looking at an environment that defied their understanding of oceanography. They were looking at an entirely closed ecosystem, operating completely independent of the sun. But studying this phenomenon was an incredibly hazardous operation. The ROV Hercules is a highly sophisticated piece of equipment worth millions of dollars, packed with sensitive scientific instruments, sensors, and high-definition cameras. Pushing this delicate machine through the halocline and directly into the brine pool was an immense gamble. The water inside the pool is not just saltier. Its extreme density creates a physical wall of hydrostatic resistance. When the pilots attempted to lower the ROV's robotic arm into the pool to collect sediment samples, the instruments reacted as if they were being forced into a thick syrup. The high viscosity altered the thruster dynamics of the vehicle, threatening to trap the craft if it sank too far into the heavy liquid. Worse than the physical density was the aggressive chemical threat of the brine. The hyper-concentrated hydrogen sulfide and methane gas bubbling out of the pool are highly corrosive. The moment the ROV broke the surface of the lake, these gases began attacking the metallic seals and delicate external sensors of the vehicle. Any prolonged exposure risked permanently frying the electrical systems, blinding the cameras, or corroding the mechanical joints of the multi-million-dollar sub. The pilots had to hover Hercules with absolute precision, fighting subtle internal currents and the buoyant resistance of the brine, all while keeping a safe distance from the toxic bubbles breaking across the surface. The tension in the control room was palpable as the team realized the sheer fragility of their position. If the ROV suffered a thruster failure while hovering over the cauldron, it would sink directly into the anoxic graveyard below, joining the pickled mummies of the sea creatures it had come to study. Every second spent taking temperature readings and collecting fluid samples was a calculated risk against the corrosive soup. When Hercules finally pulled back from the shoreline and ascended back to the surface, it carried data that shattered existing biological frameworks. Remarkably, this pool of death is not an isolated anomaly. It is just one peak in an invisible global chain of underwater underworlds. The global underworlds and the extraterrestrial paradox. While the Jacuzzi of Despair remains the most infamous underwater cauldron, it is far from an isolated anomaly. Oceanographers have mapped several dozen of these subterranean dead zones scattered across 3 highly specific regions of the planet: the Gulf of Mexico, the Mediterranean Sea, and the Red Sea. In the sprawling, deep ocean trenches of the Gulf of Mexico lies the Orca Basin, the single largest brine pool ever recorded. Measuring a staggering 21 kilometers long and 7 kilometers wide, this gargantuan abyss forms an underwater inland sea filled with nearly 8 times the salt concentration of the surrounding ocean. Farther east, deep within the Red Sea, lies the Atlantis Too Deep, an environment where the brine pool is violently heated by active magma chambers to temperatures exceeding 150 degrees Fahrenheit, creating a superheated, highly pressurized soup of toxic heavy metals. Yet, as terrifying as these abyssal dead zones are, the ultimate paradox of the brine pool is that they are not entirely dead. In fact, they are thriving. The absolute perimeter of the pool, the thin, highly volatile boundary line where the toxic brine begins to bleed into normal seawater, is a booming oasis of biodiversity. Because the dense pools trap falling organic debris like a safety net, millions of chemosynthetic microbes gather along the shores to feed on the raw methane and hydrogen sulfide bubbling out of the trenches. These bacteria do not need sunlight or oxygen. They convert pure chemical energy into sugars. In turn, dense, towering carpets of deep-sea mussels, tube worms, and specialized shrimp colonize the edges.
The mussels they've done a stand-up job at keeping the walls intact. So I think, initially probably what happens is fluid starts to erupt from the seafloor through a fissure,
forming an entire ecosystem fueled by the very toxins that kill everything else. This stark juxtaposition of immediate death and thriving, bizarre life is why the global scientific community is obsessed with discovering new brine pools. They serve as the single best real-world analog for astrobiologists looking to detect alien life elsewhere in our solar system. When NASA probes send back data from the icy outer moons of Jupiter and Saturn, specifically Europa and Enceladus, the telemetry reveals deep, global oceans buried beneath miles of solid ice sheets. Scientists strongly suspect that the floors of these alien oceans are fractured by powerful tidal forces and salt tectonics, forming deep-sea environments remarkably similar to Earth's brine pools. These hidden regions may share the same chemistry, temperature ranges, and pressure gradients found in some of the most extreme habitats on our planet. If life is capable of surviving on the edge of a pitch-black, toxic, and anoxic cauldron at the bottom of the Gulf of Mexico, then there is little reason to believe it could not also thrive beneath the icy oceans of an alien world. Every time a robotic submersible pushes its camera through a terrestrial helicline, it isn't just peering into a deep, forgotten graveyard of our planet's Jurassic past. It is catching a glimpse into the very crucible where life first emerged on Earth. and mapping the exact blueprint for finding life across the stars. Hidden beneath the waves, these toxic lakes prove that our planet still harbors deep alien secrets. They are places where the line between absolute destruction and the origins of life blurs into the dark. If you want to continue exploring the most surreal, uncharted corners of our world and beyond, make sure to hit that subscribe button so you never miss another deep dive into the unknown.